Hello everyone, welcome back to my YouTube channel, and we are continuing our journey on CKA certification. Today we'll be looking at service and networking, which covers about 20% of the exam weight. We'll be using a playground from Kilocoda, and we'll be looking at pod-to-pod connectivity. I got a couple of commands here. We'll talk about them. Then network policies, different kind of services that we have, then gateway API ingress controller. Today is kind of loaded session, but I have added enough details here that should be able to help you in grasping the subject. And we'll be talking about API gateway versus ingress resource. Then finally talking about bit about core DNS, and I've as always included some homework for you where you will be able to go and run some commands yourself and basically gain the hands-on knowledge that one needs to pass these exams, right? So let's talk about pod-to-pod connectivity. So by default, when you deploy services in Kubernetes, they are able to talk to each other, right? So you can literally copy this and it'll kind of copy paste all the commands, but I'll do it one at a time. And let's see, let's say kget nodes. Yes, we have two nodes, one control plane, one worker node. So what we are doing is deploying a pod named Nginx pod, right? So it runs on port 80, kget PO, and you can see it is creating the pod, right? Then let's kind of wait for it to be in running state. Yes, it is already in running state. And if we look again, it says it is running, right? What we are doing here is exposing the deployment. During the exam, writing a YAML file is okay. You can do that, but problem with that is it'll take longer for you to write a YAML file and then finally be able to ensure that you are not having any syntactical errors in that, right? So better option is use the imperative commands like I'm doing here: kubectl expose deployment, name of the deployment, then what name you want the service to be given, what port will it be, because this one, our deployment is listening on port 80, that's why I target port 80, and this port is where service will listen. Okay, so that's the difference. So uh, I've seen people get confused between these two, target port and the port. So when you do describe to that service, you can see here target port is 80. This is where traffic will eventually go and land on, right? So what does it mean? It means we are running a pod with this IP. So if we do kget po hyphen o wide, and you can see this is the IP of the pod, and then colon 80. This colon 80 is where it is running. That's why target port is 80. And this one, the port, is where service listens. Okay, so assume service is kind of a load balancer. That is what it is. By default, it does expose. When you run expose, it goes as cluster IP, right? So a service is created. Now we are going to create another pod. Again, if you notice, most of the commands I'm doing imperatively rather than going and creating a YAML file, I'm doing it imperatively, right? So let's see, container is getting created. We can see one container is created. It is 1.5 named a busybox. It'll be talking to this Nginx pod now. To do that, let's see, can it do the NS lookup, right? Can it figure out the IP of the service? So the naming convention, the way it works is your name of the service. So here we have the service name. This is where we created that service, right? So service, and then the namespace, because the service is created in default namespace. That is why it is like that. what type of object it is a service type object, then cluster.local, right? This is the kind of full suffix, and this is the fqdn. So when you query it, that's how you are getting this ip, and you can see this is the ip of that service, right? So here I am getting inside this busybox container which we just created here. It is sleeping for 3600 seconds. Inside that container, I'm going and running ns lookup, right? So that is good. It is able to do ns lookup. Basically, busybox is sending a query to kubedns, and that's how it is getting an answer, right? So let's see, if I get inside the busybox, can I query our service? So I'm in a busybox pod, I'm querying this, and on port 8080, if you see, that is why I said, this service or this hyphen hyphen port is where your service listens. So your service is listening on port 8080. That is how I am able to get this data, right? But what if you want to kind of connect to the pod? So I'm in the next command. It does look fancy, but there is nothing special in it. What I'm getting is, I could have literally copied IP from here, right? The Nginx pod. What I did by running this command, I added that value of the IP uh, inside this variable, right? Why did I do that? Because it becomes easy when you are kind of using it or to run commands, right? So exactly same command that I was running here, but we are running against the pod IP, and I'm not specifying a port number. Why? Because by default, if we don't say https, it is by default going to port 80. If we do https colon slash slash dollar ip of nginx pod, then it is doing 443. So right now request is going on port 80, and you can see our busybox pod is able to talk to our nginx pod. So here is our busybox pod 1.5. It's able to talk to 1.4, right? That is what networking between two pods, that's how it works, right? When a pod is created, the way kind of networking works is, underlying machine has some interfaces. Let's see if I can show you SSH. Let's see, if config. So you can see this underlying machine has this interface, right? ENS 0, then it runs Docker, then it is running. Looks like these guys are using Calico, and Calico is creating kind of virtual Ethernet pairs. So the way it works is, um, whenever you spin up a pod, your pod gets one side of the veth pair or virtual ethernet pair. So it's a kind of pipe getting created. One interface gets created on your machine, another interface gets created inside the container namespace, right? So that is how kind of networking works. So if we, let's say, we were getting into this, I'm not sure if it'll have this if config, but um, we can see the kind of hardware address, but we should be able to figure out uh, net stat nr. You can see where it is going, what is the gateway for it. Default gateway, it says 169.241.1, and then arp hyphen a, and now it says it has kind of learned two MAC addresses, but you can see this is how it is showing the you know Ethernet address. Uh, if you are using, let's say, some other CNI, you will see the kind of a MAC address for that. Just from the exam point of view, just understand all these pods that you create, if you don't have network policies, they are able to talk to each other, right? How do you control kind of connections of these parts, right? So that is where network policy comes in play. How does it work? So this policy is for default namespace, and it says only allow front end. You can write anything, this is just a name, right? But we what we are saying is look for the pods that has a matching label named role db, right? So it should have a label, and that label should have a value named as db, right? So only those pods it should kind of get applied on. What type of policy it is? There are two types of policies. One is ingress, another is egress. In in case of ingress, it will always be from, because ingress means coming inside, egress mean going outside. So in case of ingress, it will always have something called from. In case of egress, it will always has to. So if you know ingress, you can literally rewrite it very easily. So ingress will become egress, and then you'll see egress 2, and this remaining section will remain same, right? O- or you can do a ingress and egress both also, that is also allowed, right? So ingress egress both are allowed. Let's go to network policies, and I'll show you one example. So you can see here ingress from, right? So from IP block, namespace. So ingress is allowed from all these, either side, these siders, except from a this cider, right? So if you want to kind of block it from a single IP, you will do 32 here, and you'll write the full IP and slash 32. You can do that way, right? So it is in default namespace. Any request coming from here is allowed except if somebody is trying to get in from this area. On top of that, it so this is or condition. You see, 1, 2, 3. This minus is giving us kind of or condition. What if this minus was missing? If you don't write this, that will make it and condition. What does it mean, right? It means you need to have a connection coming from this block and this namespace, and this pod should have a role, right? That is what it will become if that minus is missing in front of these, or the hyphen is missing, right? So that is kind of and condition without hyphen in the beginning. With the hyphen in the beginning, it is or condition. Connection from this will be allowed except from this, or a connection from my project type. If somebody created a namespace, and namespace has a label named project and value is my project, connection will be allowed. Similar story, from in terms of pods, you are saying a pod, if a pod has a label named role and value is front end, connection from that pod will be allowed, right? Ingress connection. And then you see what I was talking about, right? From and uh, these are all kind of or conditions, and this is a and condition. Why? Because it doesn't have that hyphen in front. So connection from all these guys going to 6379 port are allowed. So if somebody try to go to port 80, that will not be allowed, because when you define one policy, that kind of blocks everything else, right? So that is how you are kind of selectively allowing things. That is how it works, right? Egress, you are allowing connections to a particular IP block. You can have accept condition here too. You can, here you can see these two, and hold on, let me see. To and see the each network list, each rule allows traffic which matches both to and ports section, right? So that is a and condition which I was talking about, 575978, right? So that is and condition, because this ports doesn't have a hyphen in front of it. So what it means is, two these two conditions, when both meet with and, then only connection will be allowed, right? So that's a kind of nuance you need to understand. See here, they kind of very clearly go into in detail. Policy contain a single from statement. It's a single from statement. Element allow connections from pods with the label client and namespace label, but uh, with the label Alice, right? So it is doing kind of a and condition. So both need to meet. Label, user label should be Alice, right? And role should be client. So this is a and condition. If you see this, this is a kind of or condition. It contains two elements. This contains one element because of this hyphen. Here, one, two. This is two elements. So remember this. That's what it says, or from, right? So if you have hyphen, it is or. If you don't have hyphen, it's and condition. Just remember that. Very important to remember, because during the exam, I've seen people kind of struggle, or after exam they come back and share their experiences. Anyways, those are network policies. I'm not implementing anything, but you can literally assume, like, we have two pods running, right? So if I do k get po, we can see one busybox, one nginx. Nginx is listening on port 80. We can define a policy that says block connection from busybox. um, we can do that. We can create another namespace and say from that namespace it should be allowed, but from default it should not be allowed. We can think about doing those things, right? We can do based on label on the pod. We can do it based on IP address. We can do based on ports and all. So how do you know what options are there, right? K explain netpol, right? So netpol is a short form for network policy. So do spec, right? So inside that spec, you have two types of policies, egress or ingress. Let's see ingress, right? Spec dot ingress. Now in ingress, you see two fields, from and ports. So so ingress dot from. Now these are all fields that are allowed: IP block, namespace, pod selector, right? Then if we do, instead of ingress, we had another field. Instead of from, we can do port. I didn't copy it. Yes, dot ports. So ports, and you can see what ports or what options it has, right? So reading this also is important. For example, it very clearly says, is it an int-arg, or is it integer, or is it a string type? In some places you will see it shows this thing in the beginning, this bracket. That means it is a kind of array. It will have sub values in it. So anything that has this thing, that means it has sub values inside it. You'll have to use kind of a four spaces or two spaces to kind of write anything, right? So for example, from, you see, here are spaces that you need to give. After that comes IP block, right? So let's say from, then it says IP block. You are giving spaces, and let's see inside the IP block. So from dot IP block. Let's see if it can explain, right? So IP block has fields, for example, cider or accept. And you can see this also has similar type of setting, right? You can define multiple of these, right? In cider also you can do that. So it is not very consistent, but still It's a indicator that could help you save some time. What does it mean when you are doing this kubectl explain? Okay. All right. So, what type of services do we have in Kubernetes by default? One is cluster IP, the one we saw. It is default pod to pod internal. As I mentioned when I created that service, remember I created this expose uh, uh, during this one. So by default, it created cluster IP. It is not externally available. What do you mean by externally available? That means if from my laptop, if I try to do curl to the IP that it gives, k get svc, for example, this IP, it is internal to cluster only. Nobody can reach it from outside. It's not a basically kind of a routable IP on the internet in simple terms, right? Another type is node port. Node port is a special type of service that gets created when you use hyphen hyphen node port, right? So you can do it this way. It is gonna allocate um a port within a kind of given series. Hold on, let's see. Node port, and if you see here node port, you can see default range is 30,000 to 32,767, right? Now the way it works is your pod is running on, let's say, node 1, and within your cluster you have 20 nodes, and you don't know from externally, you don't really need to know what node your pod is running on. You can use node's IP address, which is externally accessible. You can do a curl to that IP address. For example, if you are running HTTP server, right? Assume your service is listening on port 30,000. You'll do curl, pick up any node out of those 20 and say port 30,000. You'll be able to get the answer. So the magic happens behind the scenes. Q proxy is routing traffic between different nodes. So no matter where your pod is running, Q proxy is sending your traffic to the right node where your pod is running, and you are getting the answer. Right? What are the problems with that? With this, imagine you are running it on a cloud service provider, for example, AWS. If you do this, you're gonna incur inter-AZ data transfer charges if your connection landed on a node which is not in the same availability zone where your pod is running, because your Q proxy will send your connection from there to another zone, and from there you'll be kind of getting data, right? So another thing, if you use node port, every time you'll have to specify or remember the port number. Imagine you had to do that to access Google. Had assume Google was running on port 30,000, Gmail was on 31, and then Google Drive was on 32, documents were on 33. It will be mess, right? You need to remember those port numbers. It's not human friendly, that's why, right? But the way it works is it has three kind of things, right? I think I have done some work on this one in a previous lecture too. So if you go back somewhere here, I did cover service and, hold on, yeah, troubleshooting, networking, and service. So if you go on this video, you will be able to kind of dive deeper into what I meant by those three items, right? When I was talking about this port, target port, and node port. Right? Mm, Only kind of difference in all this was this thing is additional, because this is where connection is coming and hitting from outside. Somebody is doing curl and he or she is pointing their curl to a node's IP. They don't know where pod is running. All they know is this is the IP address of the node and this is the port where service is available, right? So they make the connection. That's why you need to write a node port. Target will be where to send the traffic, possibly kind of in the back end, right? Then what port you want your service is listening on, similar to kind of service that we looked earlier, right? So okay, get svc, okay, describe svc, nginx svc. Remember we talked about this target port and then the port. So port is where your service is listening, target port is where your endpoint is listening. Endpoint is the container running inside your Kubernetes cluster. All right, getting back to what we were looking at, uh, I'll kind of push it forward and let's see. All right, so that was node port. Third type is load balancer. If you are using it with cloud service provider, and you can use type hyphen hyphen load balancer. You don't need to remember this also. So you can do kubectl create svc hyphen hyphen help. This also tells you, it tells you what type of, right, services you can create. External name is a new one, very recent addition, and you can see how you create the external name, right? So again, I don't need to get into too much details. When you are running it kubectl create, you can define what type of entry you want to create, for example load balancer type, then you give it some name, right? So let's see if we can, for example, we do load balancer hyphen hyphen help, and you can see in the help section, uh, create load balancer mylb and where the connection will go, right? This is how you can create a load balancer. And then in that case, how it is different from node port, you don't need to remember the port number, that random big port number 30,000 something, right? You don't need to remember. You kind of simply go on, for example, google.com, right? That's how this load balancer type of service works. But it works on cloud service providers only because they have CRDs running that can interpret what kind of request you are submitting. Those CRDs are going to make calls to, for example, network services, EC2 load balancer, and they go and provision the infrastructure. If you are running it in your own test lab, your own test environment, or on premises, you'll have to use some sort of tooling like open source. There is something called metal lb, right? You will have to use something like that, basically making your cluster aware of your infrastructure that can spin up load balancers for you. That is the idea behind it, right? Uh, all right, I'm not gonna kind of show you a demo on how to do it, but again, you can look into your endpoints and how to do it. I've given some commands here. Uh, I'm gonna keep it very high level, but if you do this, you can, for example, give the name of the service also, right? So you can get a particular endpoint. Yeah, endpoints is disappearing. It is getting deprecated. So endpoint slices, right? So that is what you should use. So if you use endpoint slices and don't specify anything, and then you can see what are the endpoints, and from the name you can figure out what service that slice is for, right? So earlier it used to have a kind of API reference for endpoints that is getting deprecated. That's why you see that warning. All right. Next is gateway API, and ingress controller. Uh, well, before we do gateway API, I think we should talk about ingress, right? So the ingress, the way it used to work was, first of all, name ingress. In means coming inside, ingress, right? Traffic coming from outside within your cluster. And you want to shape that traffic a little bit. You want to control. For example, you have a DNS entry, and if somebody makes a request to this IP, you want for example, traffic comes to my app example.com. What service in the backend should serve traffic, and what port should that service get sent to, right? So this was very simple. But what if you had, for example, a checkout? You can have another service serving checkout. You can have a catalog, for example, here path slash catalog, another service serving catalog. So it is, for a user, it is one cohesive unit. All they see is myappexample.com, but in the backend you have split that service into multiple microservices, right? And then you control where that traffic will land. So that was the kind of functionality of ingress controller, right? So you deploy something called ingress controller, and these ingress controller were provisioning kind of load balancers for you, right? And uh, these ingress controllers, they were easy to use, but at the same time it it was kind of overhead. Why? Because to use these ingresses, you had to go and add annotations. Only one team could control. It was not easy. Again, I have given links to read more about ingress. You can go and read here, right? You need to kind of deploy ingress controller, and that's how you kind of use it. There are additional controllers that are listed here. There are so many. Some are kind of freely available. I've seen people use Nginx, for example. Very easily people go and configure and use it. Right? First, you need to create an ingress class. Then you have CRDs running. Those custom resources are going to use this. Whenever you deploy this, you use an ingress class name, and that's how it knows, right, which ingress to use, right? You had to do all kind of annotations in it, right? Then next iteration comes as gateway API. So it is, that's why I mentioned it's a evolution of ingress, right? Gives you greater flexibility, multi-tenancy, meaning north south means traffic within, coming within the cluster, going out of the cluster. You have better controls with the gateway. It also helped to kind of segregate different roles and responsibilities. For example, your cloud infrastructure management team will go and create gateway class for you, right? So this gateway class, your cloud infrastructure management team is creating. Then you can have another team, or within your business unit you have a team which is kind of little more specialized. They create a gateway, and this gateway controls what type of traffic is allowed on this gateway, right? You can even have names. You can have here, similar to what I mentioned here, myappexample.com. You could have something like that here, right? With the host entry. Then finally, application teams, when they consume it, they have full control of deploying the HTTP routes, right? So you see it is kind of divided into three phases. One, a team going and defining gateway classes. Second, a team managing gateways. Third, application team freely being able to deploy HTTP routes. You can do a lot more in this, not just kind of creating paths. For example, I've shown here slash instead of slash. You can have for example, checkout, and catalog that I was mentioning, right? You can do that. On top of that, you can also do traffic mirroring. You can do, if I'm not wrong, I think it allows traffic mirroring too. You can do for example, 60/40 traffic split, right? All those kind of advanced scenarios are supported, which were not available in Ingress. Sharing of a gateway is much more easier as compared to Ingress. Ingress was single resource that one had to deploy and manage. Maintain one error could cause all kind of problems, right? So I mentioned here role based. It is a role oriented design. Infrastructure are kind of defining multiple, then you have cluster operators, then you have developers, right? Gateway class, you create gateway, then route, you could have a grpc route too, right? So the way it works is a request comes, goes to the route talks to gateway is again supported by your gateway class, right? So there are examples given on this page. I don't want to go very deep into it, but you can see how it gets defined. You are giving it a, so how do you kind of link http route with a gateway with the help of this parent ref? So with the parent ref, you are saying uh, this example http route should talk to this gateway. Remember, I was showing you this, right? This http route should talk to this gateway. That is the HTTP parent ref that we are talking about, right? And then what host name it is allowing, what type of matching rules we have, all that you can do in kind of gateway class, right? So the way request flow works is client makes a request goes to gateway. Again, the gateway class we were talking about, that's hidden, uh, that created the gateway basically, right? So once request hits the gateway, it goes to http route. Then you have routing rules, because http route is nothing but routing rules. You can see here we are writing what backend should it send traffic to, on what port it should send traffic to, right? So your traffic rule routes are happening. This is telling the backend what, where it should send. So when I say backend refs, this is what it is talking about. This is a service, cluster service. Okay, so a request comes, goes to gateway reads the http route. Based on that, it figures out what is the backend, where should I send, and what service will handle. It goes to service knows how to kind of route traffic to pods. This is how your gateway API works. Yeah. Again, I don't want to spend too much time kind of deploying this and showing you. I would highly recommend going through this, reading this, and try creating this. I don't believe kubectl let you do this uh, imperatively. So better option is for ingress as well as gateway API, right? The ingress, the way it work, it was very different, right? So for ingress and gateway API, I would say these three, spend some time, create these things manually, go copy paste this content, understand why a, for example, why listener is written here, what other attributes could be possible, right? So you could, uh, if you want to use it, you need to kind of deploy CRDs. See, it says gateway API is a add-on, right? And you'll have to kind of deploy this. Similar for ingress also, you need to define some add-ons. And then another thing to notice is ingress is frozen. Basically, ingress will slowly get replaced by gateway API, right? So better option for you is understanding gateway API. For the exam, you should still know ingress. You should still know how ingress works. You should still be able to troubleshoot ingress. You should still be able to go run commands and figure out where ingress is running, what output of ingress YAML file means, so that you can troubleshoot, right? You could get a exam question something like, create a ingress that routes a particular, for example, slash login to a particular service on a particular port, right? How do you create ingress? You should know. You should also remember what namespace they are talking about, right? So these are some important things. for ingress. I've given links to all the documentation. You should be able to follow through and read more. I've given a table which talks about what gateway API does, what ingress does, and why ingress is better. If you start reading through it, for example, it's a single object, right? Here you have multiple objects. It's broken down into multiple pieces. The more we break it down, the more easier it becomes to manage. It's a kind of gist of the story of similar thing, right? Microservices. The more you break your application down into microservices, every piece becomes manageable as a single unit versus one monolith. Similar story here, right? Extensibility, it has very high here. I was talking about annotations you need to use, right? And you have only one ingress class. Here you can have multiple kind of gateways, multiple gateway classes also, then multiple HTTP routes. All that is possible. Then multi-tenancy, it is built in. It is very hard to do separate traffic domains. CRDs extensible. Here it has few. It is growing, as I was showing you. More and more gateway API is getting adopted. This is already mature, but at the same time, you saw in official documentation, it is kind of frozen now, right? And then fine grained access control you could do, and you should do, versus it is not easy, right? That was one of the reason why it was broken into gateway API. It is evolving, it is less mature versus ingress being very mature. You'll be able to see many examples of ingress being used on internet, even in Kubernetes documentation too, versus gateway, which is kind of limited, right? It adds a little bit more complexity because now you are managing multiple YAML files. This was very simple implementation. That's why it lacked several things that are kind of fixed, because now we have more YAML also, right? So everything has its pros and cons. I kind of listed those here. Finally, uh, CoreDNS is something that runs in each of the deployment that you go and create in Kubernetes, right? So let's see. So k get ns, and you can see here is kube system, right? K hyphen n kube system get deployment, and you see there is a deployment called CoreDNS, right? And hyphen o void, and let's see. Okay, and k get po hyphen l. I hope we have a consistent label on this. Hyphen o wide, and you can see you have two parts running, both are running on node 1, right? So if you have multiple kind of mm, nodes, you will go and run it on more nodes, because this also need to scale, right? So this is running as a deployment, but in cloud service providers, uh, there might be a possibility that people might be using it as daemon set too. But again, deployment is kind of by default standard approach. But if you use core DNS, because all the requests are landing on core DNS, you need to remember to scale your DNS pods too. You need to make sure your DNS pods are highly available. When I say highly available, this setup is not idle. This because what if node 0 dies, node 01 dies, both of your pods are dying. It's kind of leaving your application not being able to resolve or do ns lookup or DNS resolution, right? So if you have multiple nodes, make sure your pods are not running on the same node. You can very well use node affinity, anti affinity, pod anti affinity. I would say do pod anti affinity so that no two pods land on one node. That way, you are kind of ensuring highly available DNS for you, right? there is not much you need to do during the exam, but you should know where does it run, from where name resolution is coming, right? So yeah, this is what I was trying to dot svc. Let's see if it let me. So because it is trying to do fqdn resolution, I think that is why. So what it is trying to do is, you can see here it added this section, then it tried this section, then again it tried the same thing because it is trying two times. Dot, let's say default, then let's try adding this, and you can see k get svc, and Kubernetes IP is 9601, right? So this is how you'll get a response. Again, it is kn cube system get cm. You can see there'll be something for codens also. This is how configuration is managed, or config map. Get cm core DNS hyphen o YAML, and you can see how core DNS is defined. Where is it sending kind of resolution, any request that is coming, where it is going. Internally, it will try to resolve all these, then finally it will send to hcresolve.conf. So where is this resolve.conf? Inside each container. So I'm getting inside busybox, and inside that, if I go and check resolve.conf, it is set to this 96.10, and n dots is how many dots it should, up to how many dots in the fqdn name it should try to resolve. And that's why we were seeing these errors when I tried doing ns lookup for Kubernetes only, right? So I had to do fqdn, and that's how it worked. But anyways, these are few things that you need to know and remember during the exam. I don't believe they're gonna test you on this, but still understanding how name resolution works within a pod, uh, it it helps you immensely. You'll be able to solve questions better. And with that, I'll be closing. And yeah, good luck with this. If you have any questions, or you like me to go deeper into any of these sections, or you want to see a implementation of gateway API or ingress controller, a functional thing, rather than me just talking about a theory and telling you to go and do it yourself, right? If you want functional, you want me to do it and record a video, let me know. As always, I am going to post it on YouTube. You can comment on YouTube, or you can go and comment on it on my LinkedIn. And I'm looking forward to completing this course, and the last section would be on storage. And with that, it will complete the course. And uh, it took me from May till November all the way, because in between life got busy and I couldn't record. But I'm hoping that by next week I'll be able to finish this. And with that, good luck, take care. I'll see you possibly next week or next to next, because I try to do it every 15 days. But before we get in December, I'll close it. Take care. Have a good one. Bye.